In Exploration 2, we're going to continue talking about chemical bonds, but specifically as they relate to the properties of water. Now, we discussed in the introduction about how the water is an incredibly important molecule, and we're going to look at what makes it unique today. First of all, if you remember yesterday, we talked about covalent bonds and how a covalent bond is where two atoms share electrons. But sometimes those electrons are not shared equally. And so when you have that unequal sharing, we create what's called a polar molecule. All right, again, polar molecules are when two atoms share electrons, but one atom pulls those electrons closer to its nucleus than the other. And when that happens, those negatively charged electrons create charged ends of the molecule. So a polar molecule is, like I said right here in the textbook, a molecule with a slightly positive electric charge and another part of the molecule that's slightly negative. Okay. The more equally charged the atoms are, the less polar the bond is, because the atoms are going to share them more equally. And this typically has to do with the size of the atom. The larger an atom is, the more protons it has, and the more likely it is to be able to pull those electrons closer to itself. All right. So this is a picture of a water molecule. As you can tell, the oxygen is much larger than the two hydrogens. And so although there is a shared electron in between these two, those electrons get pulled a lot closer to the oxygen atom, which means that the oxygen end here is going to have a slightly negative charge. The hydrogen ends are going to have a slightly positive charge. Now, this is a really important property of water because what it leads water to have is what we call a hydrogen bond. Okay? A hydrogen bond is a weaker type of bond, but it does provide some interesting properties as a result. Okay? Now, I want to make sure we understand the difference. We've talked about ionic bonds, and that's where electrons are transferred. We talked about covalent bonds, and that's where electrons are shared. And I don't want you to get confused when we talk about hydrogen bonds, because hydrogen bonds don't involve electrons. I really wish there was a different name for them because they're really not a bond at all. It's really more of a hydrogen attraction. And what's going on here is that the positively charged ends, where the hydrogens are located, are attracted to the negatively charged ends of the oxygen molecule. Okay, so and this could happen in lots of different molecules, not just water, but with hydrogen bonds, you have the negative end of a molecule being attracted to the positive end of a molecule. And that's going to give water some interesting properties. Okay, now as I said, hydrogen bonds are very weak. They're not really the same type of connection as a covalent or an ionic bond, but they are strong enough to give water some interesting properties. The first property is what we call a high specific heat. And all that means is that water resists changing in temperature. The bonds between water molecules have the ability to absorb energy. And that's really what heat is just a type of energy. So those bonds can absorb a lot of energy before their temperature changes. Okay? It's called a high specific heat. And it's good because this allows water to store that energy and then release it when we need it to. Okay, it's a really important aspect in our cells, especially. Another property of these hydrogen bonds that allows this water to do something different is called cohesion. Now, again, cohesion is when you have molecules of the same substance that are sticking together. So this would be the fact that water molecules tend to stick together due to their hydrogen bonds. This gives us, for example, what we call surface tension. Another important word is adhesion. So if cohesion is where the molecules stick to each other, adhesion is where they're sticking to other substances. Like, for example, on a glass, you might see a water droplet slide down the side of a glass. Well, the reason why it doesn't just fall off the glass is because of adhesion. The water molecules actually stick to the side of their container due to those hydrogen bonds. All right. Another property of water is the fact that it is referred to as a solvent. Now I'm going to throw a couple terms at you. A solution is where you have one substance dissolved into another. A solution has two parts, the solvent and the solute. just as your textbook says, the substance in the solution that is present in the greater amount is the solvent. So typically, like if you have a glass of water and you pour like a Gatorade packet into it, the water is the solvent because it's the substance in the greater amount. Now the Gatorade in that example would be what we call the solute, because the solute is whatever you are dissolving into that water or into that solvent. Okay. Water's been called the universal solvent before because it can dissolve a lot of things. Now, it doesn't dissolve everything, but it does have the ability to dissolve a lot of different solutes. All right, we're going to finish with a conversation about acids and bases. You might have heard of acids before. You might have even heard of bases before, but really when we talk about an acid or a base, we're simply talking about hydrogen ions. When a compound releases a proton, which is another name for a hydrogen ion, it becomes an acidic solution. Okay, so if you facilitate some sort of a chemical reaction where there's lots of free hydrogen ions, that's going to be what we call an acidic solution, very acidic. A base is where we have hydrogen ions that are removed from the solution. So if there are not a lot of free hydrogen ions floating around, then that would be what we call a base. And here's kind of the scale. So right in the middle, we have just a neutral where there's, an even number of hydrogen ions based on the substances involved. Pure water has a pH of 7. Now, as the numbers get smaller, as you can see, we have a lot more free hydrogen ions floating around. As the numbers get bigger, we have a lot less free hydrogen ions floating around. Now, we talked about the idea of pH in our lesson on homeostasis. pH is something that your body needs to maintain, and usually it does that with what we call a buffer. A buffer is a compound that can either absorb and kind of soak up hydrogen ions if a substance is getting too acidic. It can also release hydrogen ions if the substance is getting too basic. So it basically is designed to keep that substance as close to that middle ground of 7 as possible. It can trap hydrogen ions if we're getting too basic, or if we're getting too acidic. It can release hydrogen ions if we're getting too basic. All right, that pretty much brings us to the end of exploration 2.